In this case, you have a fan, and you know the radius of its blade, which is given. Once you turn it off, the angular velocity decreases, and then in 5 seconds, it goes from 10 radian per second to 6.3 radian per second. And you need to find out what is the angular acceleration, what is the angle, and how long will it take to come to the stop. So let's put out all the information here. So the mass, this is all the given information, is 2.75 kilogram. Blade radius, this is given as 18.5 centimeter. You need to change this one to the meter. 185 meter, just divided by 100. Okay, and then other information is given. It is going from omega, so this is your initial angular acceleration, which is 10 radian per second, and this is your final, is given as a 6.3 radian per second, and the time, I'm calling the delta t. You may call the time 2, but it doesn't matter. 5 seconds, it just takes the 5 seconds. Let's say for simplicity, I'm just calling this as a t here, which is, this time is the starting time t0, and this is t, so the change in time is 5 seconds. Okay, you need to find out what is the angular acceleration. The angular acceleration is denoted by alpha, which is the same as the linear acceleration. Okay, let's call it alpha, and this is equal to change in angular speed over the change in the time. This is the final, and this is the initial. So this is omega minus omega naught, and this is the time, because we always start from time t equals to 0. So that's why this is the time, the t. And then omega, just playing all the numbers here, 6.3 minus 10, the time is 5 seconds. So once you have all this number, alpha, what you get is, you'll get is negative 0.74 radian per second squared. So the magnitude of this acceleration is 0.74 radian per second squared. That's the magnitude. And now what is asking, what is the angle? You need to find it out in the angle. In 5 seconds, how many angles it has moved. So in column B, you remember the S is equal to ut plus half a t squared. This is in linear motion. The same thing, if we want to get into the rotational motion, the S is equal to theta. U is the initial angular velocity, the time, plus half. A is equal to alpha times, this is the time squared. We need to find out the theta here. What is the initial angular velocity? Is given 10. And then we are asking in to find out the time, 5 seconds. This is 5. Half. What is the alpha? Alpha is negative 74. 0.74 times 5 square. If you plug in all the numbers here, what you get is 40.75 radian. That's what you get. Okay, and then you need to, if the answer is asking in degree, then you have to change this to the this radian to the degree. How do you do that? Just, I mean, for those who are interested, radian is 180 degree. So so 1 radian is equal to 180 divided by pi. So you just have to multiply this one by 40.75, 180 divided by pi. This is in degree. When you do your math, you will get it 2336. 2336 degree. This is the angle. The last thing it is asking is how long does it take to stop the fan. Let's do it here. See, again, we're going to use V equals to U plus AT if you remember this formula here. This is in linear motion, and if I need to translate this into the rotational motion, this would be omega, the final angular velocity. This is your initial angular velocity. The linear acceleration, this is the angular acceleration, and this is the time. And if we need to find out what the time is, the final angular velocity has to be 0 because it is stopping down. It will finally stop. Omega naught is given, which is 10. Alpha is also given. Alpha is 0.74. 0.74, and then times t. So the t is equal to 10 divided by 0.74. So if you do your math, then you'll get 13.5 seconds.